determination of specific gravity of solids. And we will determine the specific gravity of a solid specimen using Pycnometer method. So, actually, this is the Pycnometer, and it is dried in the oven. It is fully dry, and the volume of the Pycnometer is 250 milliliters. And we have soil sample which is 50 gram, and I want to determine the specific gravity of this soil specimen. And of course, we have a balance here. We will weigh the Pycnometer and the soil, and we have a vacuum air pump here, and we have distilled water. Theoretically, the GS, which is called specific gravity, and it is GS. Specific gravity is the ratio of the density of a substance to the density of a given reference material. So, here are some examples for the specific gravity. Water, we all know it is equal to 1, and cement 3.15, mercury 30.56, and inorganic clays nearly equal to 2.7. And this is the some values we will use in the equation of GS. This is the equation of specific gravity, and we will calculate specific gravity of a solid using this equation. Let's look at the equation. W2 minus W1 divided by W4 minus W1 and W3 minus W2. So what are the W1, 2, 3, 4? W1 is weight of empty Pycnometer. And let's look at empty Pycnometer. It is 68 gram. W2 it is weight of Pycnometer plus dry sample. And I will put this dry sample into this Pycnometer. Yes. Now I will weigh it again, and it is 118.2 gram. And it is 118 gram. Now, this is dried, this is 50 gram dry sample inside Pycnometer. So now, I will add just very little amount of water. And I'm mixing it, shaking. Here, in this test, the important point is we should take the air outside of the Pycnometer. Again, I add some water. shaking, I'm mixing it, and trying to get a homogeneous soil and water mixture. Let's shake a bit more. But I know right now we have air bubbles inside this mixture. So what should I do? Now I will use the air vacuum pump and I will vacuum the air inside the pycnometer. So this device is taking the air bubbles outside of the pycnometer. As you can see, the air bubbles are coming to the surface of the water. This process continues until the last air bubble going outside of the pycnometer. We are observing the air bubbles right now. Now I will shake the bottle again and then try and then continue to vacuuming. Air bubbles. Okay. Now I will fill the water, I will fill the pycnometer with water right now. And I will shake the bottle and I will wait again. Now it is 350 57 gram. And now I will clean this pycnometer, and the last measurement, the weight of pycnometer plus water. Okay, now I put this pycnometer filled with water, and I'm writing the last W4, weight of pycnometer and water. Okay, now we have the values, and we will calculate the specific gravity of our specimen. So I know that weight 1, it is the empty pycnometer, and it is 68 gram. And pycnometer with dry sample, it is 118 gram. By the way, our dry sample, weight of dry sample, it is equal to 50 gram. And pycnometer, dry sample, and water is 357 gram. And lastly, pycnometer and water is 326 gram. Now we will use this equation weight 2 118 minus weight 1 68 divided by so we have 118 minus 68 divided by 326 minus 68 and 357 minus 118. From here we get 50 divided by 19, and our specific gravity for this soil, of course, it is 2.63. Okay, today Abdullah Gül University Soil Mechanics course, first lab session, determination of specific gravity of solids, and we take 50 gram soil, dry soil, and after these steps we calculated the specific gravity as 2.63. Of course, you should use the same dry sample and you should repeat this procedure at least 3 times and you will get 3 GS specific gravity values and you will take the average of them, and that is the correct specific gravity for your soil specimen. That's it.